Welcome everyone, welcome to our channel. In this class, we will try to learn some preparation of some important fertilizers, which is an important topic under the CBCS curriculum of chemistry major and minor aspirants. Okay, so specifically, we will try to learn the preparation method only in this class. So first, we will go through this calcium ammonium nitrate, which is actually written as CaNO3 whole 2 and NH4NO3. That is 1 mole of calcium nitrate and 1 mole of ammonium nitrate. And mostly, it is in short form. It is written as CAN. It is actually very much famous. This CAN means this short form is very much famous in terms of questions, because sometimes you can get some questions like what is the full form of CAN, or you can get some questions like write the preparation of CAN or the uses of CAN. Okay, so this is the calcium ammonium nitrate. It is actually a very good nitrogenous fertilizer. As you can see that nitrogen is present in this CAN product, so it is a very good nitrogenous fertilizers, and which can be prepared by treating this calcium carbonate, or you can say that by treating this ammonium nitrate solution with limestone powder, right? So you can prepare this by treating ammonium nitrate solution with this calcium carbonate powder or the limestone powder. Okay, so now what is the color of this can, or what is the color of this calcium ammonium nitrate? So now the color varies from white to gray, but the actual color depends on the quality of this limestone powder you are using. Now if the dolomite limestone powder you are using, then the maximum percentage of nitrogen in this can be up to 20%. Okay, but that nitrogen percentage can be increased. And how is it possible? Now if this limestone whatever you are using, if that amount is smaller than that of used ammonium nitrate, then the percentage of nitrogen can be rise up to 28%. That is the maximum percentage you can achieve. But whatever these canned products we are using in the industry, the maximum percentage in all these products are up to 21%. Okay, now we will go through this preparation in brief manner. What is happening here, that is, in this kind of manufacturing of a can, it is involving the reaction of this calcium carbonate, that is limestone powder, with nitric acid in presence of ammonia. Now why ammonia is being used? Because it is actually neutralizing the excess acid, that is the nitric acid. Okay, now in the first step, what is happening? That ammonia is reacting with nitric acid to produce this ammonium nitrate. Okay. Now, what after that, what is happening? That we are using this calcium carbonate or limestone powder is being used. Why? Because in the first step, while you are forming this ammonium nitrate solution by reacting this ammonia with nitric acid, some of the nitric acid may be unreacted, right? So that will be excess, right? Excess in manner. So those excess nitric acid should be neutralized, and for that reason this calcium carbonate we are using. So this calcium carbonate will actually neutralize this nitric acid. So what will be the overall reaction? The overall reaction is calcium carbonate reacting with ammonia and nitric acid to form this calcium nitrate and ammonium nitrate, and the CO2 and H2O will be released. And actually this is a double salt. You have already heard the term that is a double salt. So it is a specific example of double salt, that is calcium ammonium nitrate. So now after cooling the solution, actually you will get the granules of can. Okay, so this is the overall preparation or manufacturing process of can. So now we will go through the usages of this can or calcium ammonium nitrate. In the first point, it is written as fertilizer. So can is actually a granulated nitrogenous fertilizer that applies nitrogen to plants in a very balanced and secure manner. In the second point, coming to the second point. Now, as you can see that in can, there are two types of nitrogen. That is one nitrate type and another one is ammonium type, right? So due to these two types of nitrogen, can becomes a special product with neutral pH. And these excellent granulation of this can and specific surface coating has a very good spreading properties. And now coming to the third point. can is actually a valuable source of nitrogen which can be applied to any type of soil or any type of plant. Okay, so this is the overall preparation and usages of can or calcium ammonium nitrate. Now on next we will go through the ammonium phosphate. Okay, so this is our second fertilizer, that is ammonium phosphate, and it can also be named as ammonium orthophosphate, and the chemical formula can be written as NH4 whole 3PO4. Now what is actually ammonium phosphate? It is a salt of ammonia and phosphoric acid. As you can see that by reacting ammonia with phosphoric acid, you can easily get this ammonium phosphate. So it is basically a salt of ammonia and phosphoric acid, or you can say that orthophosphoric acid. Okay, so now it consists this ammonium cation and phosphate anion. And if you are boiling the solution of this ammonium phosphate, the ammonia will be released. Okay, and these ammonium phosphate is basically one kind of this phosphorus fertilizer. So it can be used directly to the plants or directly into the soil, or it can be used in form of solution also. Now coming to the preparation. Now ammonium phosphate mostly prepared by reacting ammonia with phosphoric acid or orthophosphoric acid. But there is actually basically two major types of this ammonium phosphate. One is monoammonium phosphate, or written as MAP, and the chemical formula is NH4H2PO4, and another one is written as a DAP, that is diammonium phosphate, and can be the chemical formula can be written as NH4 whole 2 HPO4. That is, one hydrogen is replaced in MAP, and here two hydrogens are replaced in DAP. So basically they can be interconverted to each other by changing ammonia and these orthophosphoric acid. Okay. So first of all, how this monoammonium phosphate is prepared? This monoammonium phosphate can be prepared by reacting this ammonia with this orthophosphoric acid, and then centrifuging and drying in a rotary dryer. But how this diammonium phosphate is prepared? Now in case of this diammonium phosphate, it needs two stages. What is why these two stages are required? Because to prevent these loss of ammonia, what are those two stages? First one is the neutralization, and second one is the granulation. So this is the overall method to prepare this MAP and DAP. And how you can get these overall ammonium phosphate, that is NH4 whole 3PO4. As you can see that in the phosphoric acid there is total 3 replaceable hydrogen atoms. So to prepare this NH4 whole 3PO4, you need 3 ammonia molecules to react with this orthophosphoric acid to get NH4 whole 3PO4, or this ammonium phosphate. Now coming to the usages. As you can see that in ammonium phosphate there is no chlorine atom present, so it is a non-chloride fertilizer, and both nitrogen and phosphorus are present in this fertilizer. So this is basically a compound fertilizer which can be used in the agriculture. It can be also used in the manufacturing of these yeast products, or in the manufacture of this vinegar, or some kind of these bread improvers. And in the food industry, it can be used in the it can be used as a fermentation agent or the nourishment agent. Okay, so this is the overall ammonium phosphate and its preparation and usage. Okay, so this is our third fertilizer, that is polyphosphate. And as the name suggests that polyphosphate, what is polyphosphate? Polyphosphate means that there are several phosphate group links, right? So there should be several phosphate group links. And how it can be prepared? So polyphosphate is basically a liquid phosphate fertilizer which can be prepared by reacting ammonia with phosphoric acid, or you can say this as orthophosphoric acid. Okay, so by reacting ammonia with phosphoric acid, this polyphosphate can be prepared. Now after this reaction, whatever will be formed, the water should be driven off, and then what we will get, these phosphate ions we will get, then these phosphate ions should be linked with each other to form a chain. Now the chain length, the length of the chain can be different. There can be a smaller chain, the chain can be a larger one, but collectively or all over it is called as polyphosphate because it is having a links of different different phosphate group. Okay, so now in these polyphosphate chain, 25 to 50% of this phosphorus is in simple orthophosphate form, and that is actually available or directly available for plant uptake. But the remaining 50 to 70% of the phosphorus in this polyphosphate are in different form, and actually that should be broken by the enzyme, or you can say the organisms present in the soil, to make them readily available for plant uptake. I am summarizing once again that 25 to 50% phosphorus are readily available for plant uptake. Why? Because they are present in the simple form, that is the orthophosphate form. But the remaining 50 to 75% of the phosphorus are not in the simple form, they are different form of phosphorus. So therefore they must be broken by the enzymes or the organisms present in the soil to make them available for plant uptake. Okay, so this is the basic difference between these two. Okay, now this is the liquid fertilizer, right? So there is one benefit also. Due to this liquid nature, some other nutrients can be added with this polyphosphate to make these an excellent carrier of nutrients which can be required by different plants, right? And what is the main uses of it? Actually it is commonly used in production agriculture. Why? Because in the production agriculture, due to its liquid nature, several nutrients, several other chemicals can be added to it, can be mixed to it, right? And therefore it is very commonly used in production agriculture. Okay, and one more thing you should know, that in the polyphosphate, see these 50 to 75% phosphorus are in a different form, right? So therefore, these what the enzymes or what the organisms are doing, that they are breaking these polyphosphate chain. So they are breaking this polyphosphate chain into simple orthophosphate form, because when that will be converted into simple orthophosphate form, that will be readily available for plant uptake. Now, how many days it will require? So almost 50% of this polyphosphate can be converted into this orthophosphate form, means this phosphorus of this polyphosphate can be converted into orthophosphate form within a week itself. So 50% of these polyphosphate can be converted into simple orthophosphate form within a week itself. So this is the overall polyphosphate, that is its preparation, its structural differences. This is orthophosphate and this polyphosphate. These are structural differences and overall usages of it. Okay. Now this is our fourth fertilizer, that is superphosphate. Now the chemical formula of the superphosphate is CaHPO4 whole 2, and it can be referred to as single superphosphate, which can be written in short form as SSP, that is single superphosphate. Okay. And the scientist, that is John B. Laws, actually named it as superphosphate. Now, how this superphosphate can be prepared? Now, we can prepare it by reacting this rock phosphate with concentrated sulfuric acid. Almost equal amount of these two materials, that is rock phosphate and concentrated sulfuric acid, are reacted, then dried and cured to get a single superphosphate, or you can say that superphosphate. But there is one important topic regarding this SSP. What is that? That is, it is the first chemically manufactured commercial fertilizer. What does that mean? That it is that kind of fertilizer which has been chemically manufactured for the first time and becomes commercially available. So this is the first one chemically manufactured commercial fertilizer. And what does SSP contain? This is single superphosphate. What does it contain? It mainly contains this monocalcium phosphate and calcium sulfate. Now, this monocalcium phosphate present in these SSP or single superphosphate is actually soluble in the soil moisture, and therefore the roots of the plants can absorb phosphoric acid in that form. Okay. Now, the rest of this monocalcium phosphate solution precipitates in the soil and can form different kind of these phosphate compounds which are actually water insoluble, or you can say that those are not soluble in water and therefore they cannot leach out. Okay. a compound like dicalcium phosphate, this monocalcium phosphate, a compound like dicalcium phosphate is actually water insoluble but is soluble in carbonic acid in water, and therefore those can be available to plants. But the problem exists with tricalcium phosphate. This is mono, then we have talked about dry, now this is tricalcium phosphate. Now this tricalcium phosphate is actually completely insoluble in water, and therefore it remains fixed in the soil. So now we will look into this production. How is it produced? Okay, how we can produce these SSP or these single superphosphate. Okay, so in this manufacture of this SSP, first this rock phosphate or this phosphate rock is reacted with concentrated sulfuric acid to produce soluble calcium dihydrogen phosphate. So what is happening here? That is, this is the rock salt which is actually reacting with which is reacting with this concentrated sulfuric acid to produce these calcium sulfate and this calcium dihydrogen phosphate. Now this combination of these is actually called as SSP, because we have already told this SSP contains this monocalcium phosphate and calcium sulfate, but the primary material is, or the primary element is monocalcium phosphate. Okay, this is the calcium dihydrogen phosphate. Okay, so this is the overall reaction, that is rock salt is reacting with this concentrated sulfuric acid to produce soluble calcium dihydrogen phosphate. This is the overall manufacturing process. Now we will come to the usages of it, or the main usages of this SSP or superphosphate. So first one is it is the principal carrier of phosphate. Okay, it is the principal carrier of phosphate, and therefore it is one of the most famous fertilizer in world. Now what is the second one? Second one is it is a low cost source of phosphorus, and therefore it can be widely used because it will be the cost effective. It will be cost effective, right? And third one, see the structure of these SSP. Okay, in this SSP, what is there, or the what does the this SSP contain? It contains monocalcium phosphate and calcium sulfate, right? So in SSP, we are having phosphorus, we are having calcium, and we are having sulfur also, which are making it to offer an agronomic advantage. Okay, so this is the overall superphosphate. We have already learned about what is this, why this is means what is the manufacturing process of these, how these the short form called, and the overall usages of it. Okay, so this is the, so thank you very much for watching this video. Please like this and share this as much as possible, and for all other chemistry content or for all other chemistry related videos, please subscribe our channel. Once again, thank you very much. See you in the next class. Bye bye.